Selecting the appropriate heat trace cable for a brick walkway involves several key considerations. These include the area to be heated, the thickness of the bricks, the climate, and the power supply available. Firstly, calculate the square footage of the walkway. This will determine the amount of cable needed. Secondly, consider the brick thickness. Thicker bricks require high wattage cable to ensure adequate heat penetration to the surface. Thirdly, evaluate the climate. Colder climates necessitate higher wattage cable to effectively melt ice and prevent accumulation. Finally, determine the electrical power requirements for the selected cable to ensure compatibility with your power supply. Regarding recommended wattage, 10 watts per square foot is suitable for mild climates with infrequent icing or areas with thin bricks. 20 watts per square foot is recommended for colder climates, thicker bricks, or areas with heavy icing. Installation guidelines are important for optimal performance. Install the heat trace cable in a serpentine pattern under the bricks, always following the manufacturer's instructions. Use sand or a concrete mix to fill the gaps between the bricks and the cable, ensuring good thermal contact. Insulate the soil beneath the walkway to minimize heat loss into the ground, thereby improving efficiency. Connect the cable to a thermostat to automatically regulate the temperature, preventing overheating and conserving energy. For additional information, several resources are available. Websites such as WarmZone.com, Thermon.com, and Raycom.com provide detailed product information and application guides. Manufacturers like Warmly Yours, SureHeat, and Infloor Heat Supply offer various heat trace cable options and technical support. Books like Hydronic Radiant Heating Design and Installation by Dan Holohan and Heating with Radiant Energy by Francis Balcombe and William Ray offer in-depth knowledge of radiant heating systems. The area to be heated needs accurate measurement so you know the exact requirements for the heated area. This is the first step and the most important to determine how much cable you will need. If the square footage is off, it can either provide too much heat, wasting energy, or not enough heat, which defeats the purpose of your goal to de-ice the walkway. Secondly, brick thickness is also important to consider since the R value of the brick will play a big part in how the heat is dissipated. The thicker the brick, it might take more heat to penetrate. Alternatively, you may decide to insulate under the walkway so it provides a thermal break below the heated bricks so that the heat is not lost to the ground. Climate is something that you cannot change, so be sure that you choose the best heat trace cable for the worst case scenario. For example, you may live in a climate that does not snow often, but when it does the area gets hit hard. So be prepared for the most extreme case. Power supply is important since you do not want to overload your existing electrical circuit. Be sure that there is enough capacity for the heat trace cable, especially if there is a large area. If the area is too large, consider splitting it up into multiple zones, each connected to a different circuit. Different wattage ratings will allow different heat intensities, and the 10 watts per square foot is a lower heating value than the 20 watts per square foot. In most instances, the 20 watts per square foot would be the best bet since there is a higher heating capacity. The installation is important to follow the manufacturer's instructions, especially when it comes to the wire spacing. The closer the spacing, the more heat is provided in a specific area. Also, the heating element or the cable should never be touching or overlapping, since this can cause an overheat and premature failure. Sand or concrete mix is recommended to fill the gaps between the bricks and cable to make sure that the spacing is maintained and to allow better thermal conductivity. An insulated pad or sheet can be placed under the walkway and under the heating cable so that the heat is not transferred down to the earth. Most of the heat will transfer upwards and de-ice the surface of the walkway. The heat cable is recommended to be connected to a thermostat so that the heat cable can be set to specific temperatures and to automatically regulate the temperature, preventing overheating and conserving energy. Without the use of a thermostat, the heat cable will always be on, thus wasting energy, unless there is a manual switch involved. Make sure that the thermostat is rated for outdoor use since it will be in the elements. The websites provided by WARMS and Heat Trace, Thermon, and Raycom provide a lot of technical knowledge and installation guidelines. These are good starting points for determining the right heat cable and installation procedure for the specific application. The manufacturers provided of warmly yours, Sure Heat, and In-Floor Heat Supply are the companies that manufacture and sell heat trace cables. They are a good source to contact to get accurate heat cable information since they are the source. A couple of books are mentioned: Hydronic Radiant Heating Design and Installation by Dan Holohan and Heating with Radiant Energy by Francis Balcombe and William Ray. These are good sources for more detailed information regarding radiant heating systems. Before you begin any work, always check your local city, county, and state codes to ensure that the installation meets all local requirements. The NEC, or National Electrical Code, is a good point of reference to ensure that the heat cable is protected and installed in a safe manner. Article 427 deals with fixed electric heating equipment for pipelines and vessels. Article 426 covers fixed outdoor electric de-icing and snow melting equipment. Ground fault protection is typically required for heat trace installations to protect against electrical shock hazards. Select heat trace cables that are specifically designed and listed for outdoor use and wet locations. Use appropriate fittings and connectors that are rated for the environment to prevent moisture ingress. Ensure the heat trace cable is properly supported and protected from physical damage during and after installation. Always test the heat trace cable after installation to verify its proper operation and installation integrity. Maintain records of the installation, including cable type, layout, and test results for future reference. Periodically inspect the heat trace system for any signs of damage or deterioration and perform necessary repairs promptly. A well-designed and properly installed heat trace system can provide reliable and energy-efficient de-icing for brick walkways. Always refer to manufacturer's instructions and local codes for specific requirements and recommendations. By carefully considering these factors and following the installation guidelines, you can ensure that your heat trace cable system effectively prevents ice buildup and provides a safe and accessible walkway during winter months. Consider consulting with a qualified electrician or heating specialist to ensure proper installation and compliance with all applicable codes and regulations. A professional can assess your specific needs and recommend the best heat trace cable solution for your brick walkway. In addition, they can ensure that the system is installed safely and efficiently, providing you with peace of mind and reliable performance. Another consideration is the control system for the heat trace cable. While a simple thermostat can regulate the temperature, more advanced control systems can offer additional features such as remote monitoring and control, energy usage tracking, and integration with weather data to optimize performance. These advanced control systems can help you save energy and reduce operating costs by only activating the heat trace cable when it is needed. Furthermore, consider the long-term maintenance requirements of the heat trace system. While heat trace cables are generally durable, they can be subject to damage from physical impact, environmental factors, and electrical surges. Regular inspections can help identify potential problems early on, allowing you to address them before they lead to system failure. It is also important to keep the area around the heat trace cable clear of debris and vegetation to prevent overheating and damage. Finally, consider the environmental impact of the heat trace system. While heat trace cables provide a convenient way to de-ice walkways, they do consume energy. By using a thermostat or advanced control system, you can minimize energy consumption and reduce the environmental footprint of the system. Additionally, consider using renewable energy sources such as solar power to power the heat trace system. Solar panels can be installed on the roof of a nearby building to generate electricity for the heat trace cable, further reducing its environmental impact. In summary, selecting and installing heat trace cable for a brick walkway requires careful consideration of several factors. By considering the area to be heated, brick thickness, climate, power supply, and installation guidelines, you can ensure that the system effectively prevents ice buildup and provides a safe and accessible walkway during winter months. Remember to consult with qualified professionals, follow manufacturer's instructions, and comply with all applicable codes and regulations to ensure a safe and efficient installation. By considering the long-term maintenance requirements and environmental impact of the system, you can ensure that it provides reliable performance for years to come. The key parameters that you should keep in mind are the heat loss calculations and the system voltage that you plan on using. In residential application, most of the heating cable is designed for 120 volts. However, in commercial applications, you might have the option of using 208 volts or 277 volts. This will allow you to distribute the load better across the electrical panel. Also, remember that the heating cable is a resistive load, so the circuit breaker should be sized accordingly. For example, if the heat cable draws 15 amps continuously, the circuit breaker should be sized at 20 amps to prevent nuisance tripping. Consider the type of bricks that you are using as well. Some bricks can handle freeze and thaw better than other bricks. If the bricks are not rated for freeze and thaw, there is a good chance that they will crack during the winter time. If the area is not insulated properly, the ground underneath the walkway may freeze and cause the ground to shift, which can damage the walkway. Proper drainage is also important, since you do not want water to accumulate and puddle, which will freeze and cause damage to the walkway. You can install a French drain to allow the water to drain properly. It is also important to make sure that the connections are properly sealed so that water cannot enter the heating cable. This can cause a short circuit and damage the cable. Be sure to use the proper connectors that are rated for wet locations. One should also consider future repairs. Ensure that the bricks can be removed without damaging the heat cable. It is also recommended to take pictures of the heat cable placement before covering it up so that there is a reference of where the cable is located in case of future repairs. When using a concrete mix, it is recommended that the mix has additives to prevent cracking. Consider adding fiber reinforcement to the concrete mix to add structural integrity. A control panel can also be installed in a central location to monitor the temperature, current, and voltage of the heat cable. The control panel can also have alarms to notify you of any issues with the heat cable. In addition to electrical protection, also consider surge protection, especially if the power is known to fluctuate often in the area. A surge protector will prevent high voltage spikes from damaging the heat cable. By taking all of these considerations into account, you can design and install a heat trace cable system that is safe, reliable, and efficient.